Hi guys, welcome back to our next Houdini practice hour. My name is Helge Maus from pixeltrain. First I want to thank you all for the positive feedback I had to my lessons which I released last week, also for the thumbs up, and welcome to the new subscribers here. I had one comment under one of the lessons which I want to discuss in this lesson first before we go on, because I think it's a really interesting and important comment. So I wrote an answer and I also want to make clear what I wrote there. And the question was why I use booleans for such an easy model here, like a coffee cup. So let's talk a little bit about that and the concept behind that. So for this, I select my coffee cup here. I press Shift- to go out of the subdivision surface display. Then I dive into my coffee cup here, and you remember this here was the tree we built together in the last week. I press Shift-W here to show you here the polygon structure. And you remember we had this outside paper, and then we inserted this bottom part here as a separate branch. And everything here is procedural. And this is a really important concept. So let's start with this idea. In the other two Houdini practice hour projects, the banana project and also the toothbrush project, I worked in a so-named direct modeling approach. And this direct modeling approach is the same like you are used to work with in Blender, in Cinema 4D, or also in Maya. For building a coffee cup like this, it's a matter of some seconds to do that. But the idea behind this lesson here is that I wanted to teach you how to approach a procedural model. Procedural means that this tree here is still able to change without breaking your model. And if you ever worked in an application, for example, I know Maya because I worked also as a trainer for Maya. And I was used to delete my history all the time because Maya depended its nodes on each other, and if you then try to make a change at some point in the modeling process and the history was still not deleted, everything broke. Houdini is different at this point, but it doesn't come for free, and this is also important to tell you. Direct modeling is possible inside of Houdini. It's extremely fast if you want to have it much faster. There's a really cheap tool for Houdini, an extension which is named Direct Modeling Tools. I can link it in a description below. But this here is a procedural tree, which means that if I go now, for example, here into the height, you remember I colored my nodes where I have parameters which I later want to change red. If I go here to height and then go in here and say I want to change, for example, here the resolution, you see everything stays where it belongs. Or you go here in and say, yeah, I want to change the insert here of the whole thing, and you see everything stays intact. And this was the idea behind this tree. For this we used groups, we used promotes so that we converted groups into other things and so on, because I wanted to teach you how this process works. And also we took a look into channel referencing. And at this point here, I used this boolean. And a boolean in other 3D applications is something which normally shows, he was not able to model something like that here. So he used a boolean and booled it out. So this boolean here has a purpose, and it doesn't destroy here my topology. You see, it's still intact. So let's analyze why I use the boolean here and why I use it in my procedural trees inside of Houdini. Until this point here, let's set the display flag here, we modeled the outside paper and the inside paper, and then I split it here into two branches. This branch here, which ended here, is the paper. So you saw the outside of the paper, the inside of the paper, and so on, and everything is procedural. That means I changed the radius maybe later, the angle here, and so on. And then I wanted to glue in a bottom part into this cup. And to do that, I need exactly here on a height, which I want to give the correct radius all the time. And to get this, I went this route here. I hold down now my R key to set the display flag. You remember, if you click a node and press the R key, you set a display flag. If you press the E key, you set the template flag. This is something I taught you a lesson ago. But if you drag it also works. So let's demonstrate this so that it's out of the way. If you press the R key, you see your mouse cursor changes so that you have a little flag at the side. And if you now drag over a node, you see you set this flag directly here. So it's a little bit faster. So I went here to this boolean here, and the result of this boolean here is not a mess. I generated here a polygon circle which has the right amount here of points so that it fits exactly in the topology of my cup. And what I also did is I have a free placement because the boolean here uses an intersection here. If you take a look here, let's make the parameters here a little bit bigger, intersection between a solid, that's the reason why I closed this dummy here with a polyfill, and a grid, which is a surface. And this grid here, so now I hold down the E key and show you the paper around that here as a template. Then I go here to the boolean, and here R is set, so everything is fine. If I now take this grid here and I change to my handle tool, you see I can move this grid now up and down, and you see this polygon insert moves with the inside paper of the cup all the time. So I don't have to change anything. No radius, no adjustments here in the rest of my tree. So it works all the time. And that was the reason why I used the boolean here. So it's not for booleaning out a hole, for example. It's really generating exactly the right polygon at the right point. And so this is a use of boolean, which I see a lot also from my colleagues in procedural trees inside of Houdini, and I use it in my practice a lot. So I hope this clears the whole thing a little bit. And if you have more questions about that, write me in the comments, or you also can write me an email, and yeah, we can talk about that later. So I set my display flag now back here to the cup because we have to work today a little bit more with this cup. You remember you can get all my data on Gumroad. So I will finish this project with these lessons here, and then we have the first project here on Gumroad, and I will update it farther we go so that you get the next projects also. So what we want to do now is, in the next step here, I want to add here the lid. And if we go to the composite view here, you see in my references that we have here this lip. And on this lip here sits this lid here. And you see that the size of the lid is exactly here the size of the paper so that it fits and it holds on the top, hopefully. So what we need, again, procedural approach, is we need the exact radius of that here. So I want to start with this here. So with this polygon here. And we now use the same technique like you saw before. I go now through my tree and I search for the right point to add my branch for the lid. So I hold down my R key and I make, for example, this here visible. And you see this was the bottom. R key again, then we have the height. You see this is the height. And here you see a primitive, but it's not the right size because then we went out with the lip. And then we had the height of the lip and we go in again. And what we need is here the lip out. So I select this here and now we have the right polygon here. And if we analyze this here now, we remember we have here this top group, which is the primitive which we used for every extrusion. So you can see that if you go here to display groups and attribute lists, and we go here to select primitives or polygons. And if you now take a look here, we can see where it sits. And you see here now that top here is this primitive or polygon. And this is exactly the thing we need. So let's branch out. I make a null object for that. And I branch out here. Okay, bring it to the side and name it. So this is the lid start. I make it black again, so that we later know what's going on. I set the display flag, and now we get everything because you get everything which is in this stream. I want to get rid of everything but this top polygon. So we take our friend, the blast node again, blast everything away. Then we select here the top polygon and invert the blast functionality. So delete non-selected. So now we only have the top left. And if you hold down now your middle mouse button, you see on this top polygon, we also have the primitive group top, which is important, and you will see that we will lose it in a moment. Next thing I want to do is I want to set my template here to the paper so that we can see what's going on. So I hold down the E key and drag here to set the template flag. Now you see what we have. We have this primitive here. And the next step we now have to do is we have to grow it a little bit to the outside. So it has to be a little bit bigger than the paper. To do that, we can use a PolyExpand node. So let's use the tab key, PO, and then we see here is PolyExpand2D. So that's the node. I hook it up. And what this node does is it grows in two directions, but always on a plane. And that's okay because we have a primitive which is flat, so the growth is okay. And if I now hold down the B key to set here the bypass flag here, you see it grows a lot to the outside. But not only to the outside, also to the inside. And we can tell here the system what we want. We don't need the inside, so output inside, we don't need that. Then we have here the offset. So we can search here now for a nice value. Say, yeah, 0.02. Maybe this growth here is okay. I don't think that it's close enough to hold here. That's a little bit too much. Yeah. And you see, maybe this is a node which I later want to change. So select the node, run again. So for a procedural idea, this offset would be cool. Okay. Now we have done this, and now we want to model now the area which goes down from this point. Here it goes out, and I remember here it is a little bit angled. Here goes in this direction, and this only goes down. So there's a little bit creative freedom now. So make a poly extrude here, and we hook this up, and I go into that. Take here my handle tool and bring it down, 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 down. Okay. And then I want to bring it out. To do that, you remember you can use, if you have the handle tool active, your mouse wheel here. And if it's too fast, hold down the shift key. And the same thing works here in these fields. So if you click into a field like that, you can use your mouse wheel here, and I bring it out a little bit, not too much, maybe something like that here. And to hold the shape, I make two divisions. So for later, for subdivision surfaces. Okay. Now you see how this here looks. Okay, nice. But now we have an open group field. And the question is, do we have to use top now? We can use it. But if you remember, you also can say, okay, we only have one polygon here, which we use, so we can't get it wrong. But if you want, you can use it. But one little hint is that if you hold down on your middle mouse button here, you see there's a top group still there, but we have 0 primitives in it. So where's our primitive gone? The problem is that the PolyExpand here rebuilded the mesh, and it added a new polygon here, and you can generate here output groups if you want. So the original polygon is gone. So we can generate these output groups, and what I want is the outside group, because we deactivate the inside group, it's grayed out. So the outside group we can name again top, because this is a name we used all the time. So use it again, top, for example, and then we can tell the system, use top. That's it. Worked fine. So name it, and this here is now the lid down route. And now we want to go up here. And what I do now is I branch again. So I go back here to this point here. And now we have top here. That's great. So make a poly extrude again. Hook it up. Set the display flag here. And bring it up until we reach the point where we want to stop, and we can select top here, only to not forget. Now is the question, how far do we want to go? If you think about this construction of this cup, we have to go as far as the height of this lip here and a little bit more, paper thick or so. So let's look up if we find this here, and you see here's the lip height. So if you click this, we see here this is the lip height, and I marked it red, so maybe I want to change later the height of the lip. So we want to reference this. We use the fast way of referencing it. So right mouse button, click here, copy the parameter. Then we go over here to this node, go to the distance, remove everything which is in there, right mouse button, click, paste relative reference. So reference is there, we press the enter key, and now we see we have exactly the right height. You remember you also can click here to see the channel expression and the value. And if you want, you can now tell the system, okay, I need a little bit more. So go in here, press with your mouse button into that, and make a plus of, this value was really small, 0.005 or something like that. So it's a little bit higher, and yeah, it will work if we change the height here. So now we can go on here to make our ideas. This is now the lid contact height. Okay. Next polyextrude. Remember to use our friend top again. We go a little bit up here. Then I go in a little bit to make here a nice edge. Something like that, maybe. And if you want, you can also use here a division. This is cool because if you have a division here, we can then set here this spine shape to curved. And if we go here in, make the distance a little bit bigger, and that here, you can see it here. Yeah, you can now start changing that. And if you now want to decide how the spine looks, you can go here to the spine control and have here really some interesting spine control things which you can use. But in my case, I only need a really small up, and so I think 2 will do the job for me. Yeah. Okay, so this is lid inner 1. We'll do some of them. And now we decide how the whole look of this thing is. So let's go in again, polyextrude, top. I insert it a little bit more like that to have here the area where the drinking maybe happens. So in this area here. And yeah, we also can add divisions later if we like, because we use top. This is later possible. Yeah, but I let it open. And let's think about. Okay, let's try this. I make the next polyextrude. Bring it down a little bit here. And the next polyextrude. This time I use the copy idea. Remember we talked about that before. We make a little ridge here. And then we go up again. Control middle mouse button click resets values here. Bring it up, in, like that here. We can have an additional division. Reset the values, control middle mouse button click, insert it like that. And now I want to stop. The next idea which we have here will be that I want to have an indentation. something like that here. Yeah, some of these cups have it, some don't have it. How to achieve something like that? The first idea maybe is to make a cut here and then bring this down and this up. But this later maybe results in problems. So what I do is I first finish it. You see, this is an organic process, which is the same if you are in a direct modeling approach. You can try something. You can bypass many nodes by pressing the B key and bypassing them to try things. And what I do now is first I want to close the cup here. So make the last poly extrude here. Use top again, only to make sure that it works. I close the whole thing here, really deep. I make some divisions and say, okay, now I first want to test this with subdivisions on. So press the plus sign here over the viewport, and you can leave here the whole thing to see now how the shape looks here. And if you want, you can also use Shift W to remove here the selection and that here. And now you see this is now the area which we have. So we can go now through the whole thing and make our adjustments here first, and then in the next lesson we make this indentation. See you in the next lesson.